Welcome to DeepEX. In this video we will create and analyze a 3D frame model of a braced diaphragm wall. DeepEX is our software program for deep excavation design and analysis. It can analyze any common wall type and support system using the classical limit equilibrium analysis method. It can perform non-linear analysis with elastoplastic wiggle springs, and it can also perform finite element analysis. In this video we will present how to step-by-step create the original 3D frame model, how to edit the location of the wall nodes, and how to edit the structural sections of all created supports. In addition, we will perform the analysis and present the various calculated results on the 3D frame model area. Inside the DeepEX software, in this example, we have already created two different design sections where we used different stratigraphy and different external loads on the walls so that we can simulate the different walls around our real project. Our first step in order to create our 3D model is to access the 3D tab, and here we can select to open the 3D model wizard. We will define here the dimensions for our rectangular shape, so I will create an excavation shaft 120 by 60. And if we go through this dialog, we can select which design section and which wall of the selected design section we wish to use in order to simulate all the surrounding walls around our project. And we can define here the location of the first support from every project corner. So I will use 50% of the support spacing. If we close this dialog, then the software generates here the 3D frame. On the 3D frame, we can select which support level to view. So it created both our support levels that we used here at -8 and at -18. We can access and review every support level. We can review the staging, all the stages where the selected support level is activated. We can access every strat on the model area, and we can select to edit the structural section of it, and then apply a section from the drop down, and we can also modify the support positions here. We can do the same with the surrounding whalers, so the software created the whalers for every bracing level, and here we can define the structural section of our whalers. And we can select how the whaler is connected to the following whaler and the loading patterns for the whalers. These yellow circles on the model are actually nodes. So I can access on a node and I can redefine the x and y coordinate of the selected node. So I will place this node at 80. This means that we start from a rectangular shape and then we can edit all these nodes in order to create something different. I will use this scissors tool and I will press on the wall, and this will add a new node there. And I will edit its position and I will place it at y coordinate 60. And I will do the same here, access the scissor tool, make a node, and I will place this at y coordinate 80. And I will place the x coordinate for both points at 80. So now I created the shape like this. If I wish, I will access this strat. I will check that this is the node N5. So if I access this strat, I see that from the top along the whaler segment A2 there is this point here, so I will place it in the new whaler segment A18. So I will locate the new whaler segment A18 and I will place it 10 feet
from N5 along A18. I will select here N5 and I will select here the offset spacing to be 10 feet. So if I press OK, the strut turns on this direction along the whaler A18. This way you can access and you can add new struts using the tools here, and I can again review every bracing level. Now I did the modification on the strut which is located at elevation -8, so if I go at -8 I can see the modified strut. Now what I can do is that I can access the different walls around my project, and here I will select this option to use a different design section, and I will select the section east and west, and I will use the bottom which is the right wall of the section east and west. So now the loading pattern from this wall will be applied on the whole selected wall on the 3D model area. This way I can access different walls and I can select from which design section they come from and if they are the left or right wall of the selected design section. Another thing I can do is that I can access a wall. I can go to the bracing levels and I will select generate bracing levels. So the bracing level is generated. It will use two bracing levels at the support elevations of the selected design section, and here I can press to edit and I can assign a loading pattern along this full bracing level on the selected wall, and I can select a design section and a support elevation, so the software can use along the bracing level at the specific elevation any loading pattern coming from any of the created design sections. This way we can assign different loading patterns on different whaler segments. I will select to analyze all the design sections here, and as soon as the calculation is succeeded, we will go on the project plan, where we can already view the whaler moment diagrams because they come from the selected design sections, and if I press to analyze the full 3D frame, the software will give me extensive results for every whaler, for every strut and every tieback if I was using tiebacks here on the model area for every bracing level. I can see results per whaler per stage, so I can review all the whalers on the different bracing levels. I can see the results per strut per stage, so I can select the strut and I can see the results here, and I can see a total cost estimation for my full project. I can see project costs, wall costs, tieback costs, struts costs, and I can see the costs in detail, labor and materials. If we press to exit, we can see the structural ratios of every strut on the model area, on the different bracing levels, and we can take a decision to redesign the struts, so we can access a strut and we can change the structural section, run the analysis again, and in some seconds we will have the new results. Thus we will come to the optimized model really fast. If we have access to the export to DXF drawings module of DeepEX, here we can access any wall actually, select to edit the wall items, and what we can do is that we can access and export this drawing to DXF. So this option allows us to export our plan view drawings to DXF, and I can also select any wall here and I can see the elevation drawing, which I can also right click and select to export to DXF. Exported DXF files can be opened with any CAD software, so we can really fast create all our project sketches.
Visit our websites in order to receive more information about our software programs and services. If you wish to arrange a free online presentation with one of our technical experts, feel free to contact us. Thank you for watching this video.